Hi class, today we are going to look at solving systems by elimination. This is the third way that we are going to be talking about solving systems. We already know that we can solve by graphing and that we can solve by substitution. Our third option is elimination. And when we are solving by elimination, what we are actually going to be doing is adding the equations together. So if we have a system that says 2x plus 4y equals 11, and 3x minus 4y equals 4, we are going to take these two equations and add them by sort of adding straight down. Okay, and we'll add each of these that are like terms together. Now, we call it elimination because the entire purpose of doing elimination and adding the equations together, okay, is that we want one variable to be eliminated. Right? One of the variables is going to go away. That's what eliminated means. Now, this is only going to work, okay? The only way this sort of works or matches how elimination works is if both equations are stacked. So we'll have one sitting on top of the other, and the coefficient means the number in front of one variable are the same. They have to be equal to each other. Okay, so these two equations have to be stacked. The coefficient means the number in front of the letter. Okay, and we need them to be the same. Now, regardless of the sign, we're going to talk about that in a minute, how it works. But this y has a 4 in front of it, this y has a 4 in front of it. Now, one is positive and one is negative, and we'll cross that bridge when that comes. I'll show you how to deal with it. Okay, so here's how this is going to work. Let's say we have the equation, the system, 2x plus 2y equals 8, and negative 2x plus 4y equals 4. Okay, the first thing that we want to make sure is that we have everything nice and neatly stacked. The x's on top of the x, the y on top of the y, the equal on top of the equal, and the number on top of the number. Okay. Our first step is going to be to find an x or y with the same coefficient. Now, again, when I say the same coefficient, don't pay attention to the sign. We'll deal with that momentarily. So we just want to see the same number in front. So if I look at this y, the y has a 2 in front, and this y has a 4 in front. So that's not the set I want to look at. But if I look at my x's, this x has a 2 in front, and this x has a 2 in front, and so this is the pair I'm going to pay attention to. Okay, so I'm going to take a look at my x's. Okay. Then I'm going to check their signs. So that's my second step. Okay, we're going to check and see if they're positive or if they are negative. Okay, and in this situation, the top 2 is a positive 2 and the bottom 2 is a negative 2. Okay, so one is positive and one is negative. If they are opposite signs, we are going to add these two equations together. So in this particular situation, right, one's positive, one's negative, so I'm going to add these two equations together. Now, just for the sake of knowing what we do in the other situation, if they are the same sign, it's going to seem a little bit weird. We are actually going to multiply 1 by negative 1. And we'll look at what that means here in just a minute. We don't have to deal with that in this situation, right? This says to add, they're opposite signs, so we're going to add straight down. So 2x plus a negative 2x ends up just canceling each other out. That becomes 0, so I'm not going to write that down. 2y plus 4y gives me a 6y, and 8 plus 4 gives me 12. So I'm now left with something that says 6y equals 12. Okay, once we've done that, This should then give us an equation that we are able to solve. So I'm going to take this equation, this 6y equals 12. This is just a one-step equation. I'm going to undo multiplication with division, and I will get y equals 2. But like we've been saying all week, right, we are not done yet. If we are going to solve a system, we need to find the x and the y value. So once we have solved for that first letter, that first variable, we then need to plug it back in to one of the original equations. Now, unfortunately, we don't have a choice of plugging in where we underline, so we don't have one that's already solved for it, so we have to plug into one of these original equations and then do some solving. So we can decide if we want the top or the bottom. I'm just going to go ahead and pick the top, and I'm going to plug this in for y. So I now have a new equation that says 2x plus 2 times instead of y, I'm replacing that with 2, equals 8. Well, I know 2 times 2 is 4, so I now have 2x plus 4 equals 8. And this is an equation that I can solve. And then again, just like we have been saying all unit, right, we can write our answer as x equals 2, y equals 2, or we can write our final answer as 2, 2. Okay. So we're going to take a look at a couple of these. Right? If we look at our second one, we're going to first identify where we see the x or the y with the matching coefficient, the matching number in front. So our y's have a 3 and a 4. Those are not matching, but our x's do. So I'm going to focus on those x's. Then I'm going to decide if they have the same sign or if they have opposite signs. Well, in this situation, this 5 is positive and this 5 is negative. So we said when they have the opposite signs, I'm going to add them. Okay, so I'm going to start adding straight down. 5x plus negative 5x is 0. Those cancel out. 3y plus 4y gives me a 7y. And a 14 plus a 7 gives me a 21. This is something I can then solve, so I'm going to undo multiplication with division and divide by 7. And that will tell me that y equals 3. As always, right, we are not done yet. We still need to find that other variable. So we need to plug it back into one of the original equations. Does not matter if you pick the first one or the second one, so I'm just going to plug back into the first one up here, and I'm plugging in for y because I found y. So I'm going to say 5x plus 3 times, now instead of y, I'm putting in 3, so 3 times 3 equals 14. So 5x plus 9 equals 14. I'll undo addition with subtraction and undo multiplication with division. So that tells me x equals 1. And again, you can write your answer either way, but just for sake of reminding us that either way is okay, this one I'm going to write as x equals 1 and y equals 3. Okay, if we look at our next example, again, we are looking to see where we have a matching coefficient in front. Okay, so on this one, it is our y's that match. So I'm going to pay attention to my y's, and I'm going to check their signs, right? The top one is a -4, and the bottom one is a +4. So because they are the opposite signs, I can add these equations, and I'm going to add straight down. 2x plus -4x gives me a -2x. My y's cancel, right? That's the whole point. We want one of the variables to cancel out. 8 plus 4 is 12. This gives me something I can then solve, so I'm going to undo multiplication with division, and I will get x equals -6. But we are not done there, right? We need to find the y value as well. We can plug into either equation. I'm going to plug into the top, but again, watch your variable. This is x equals, so I need to be plugging in for x. So I'm now going to say 2 times -6 minus 4y equals 8. So -12 minus 4y equals 8. I'll undo my negative with a positive or with addition. Watch your sign. That's going to be a negative 4y equals 20. And y equals negative 5. So again, we can write our answer either way. Make sure if we're choosing to write this as an ordered pair, our x value is going first. So this would be negative 6, comma, negative 5. Now, as I sort of hinted towards when we look through the steps, sometimes the coefficients won't be opposites. Sometimes they will be the same sign. Okay, if we have coefficients that are the same number, the same sign, okay, we are going to turn them into opposites by multiplying one equation by negative 1. Okay, so the reason why I said over here that if they are the same sign, we're going to multiply by negative 1 is because by doing that, it makes them be the opposite sign. Okay, we're going to force them to be opposites so that we can add them together. So if we look at this example, right, we have our x's and y's flip-flopped, but that's okay because our y is still on top of our y and our x is still on top of our x, which is fine. Okay, the one that has the matching number in front right now is going to be our y, so I'm going to look there. Except this time when I look at it, they are both negatives. They are the same sign. So we said if they are the same sign, we want to multiply one of these equations by negative 1. So what I'm going to have to do is I can pick either one, the top or the bottom. Just because I'm picking one, I'm going to pick the bottom. And I'm going to multiply that entire equation by negative 1. Not just one number, not just where one variable is, but that entire equation. So all the way through gets multiplied by negative 1. So my top equation stays exactly the same. Negative 3y minus 4x equals negative 11. But my bottom equation now says negative 1 times negative 3, which is positive 3y. Negative 1 times positive 5, which is negative 5x. And a negative 1 times a positive 61, which is a negative 61. Right? I had to multiply all the way through. So now when I check, my y's still have the same number in front, but one is positive and one is negative. That allows me to now go back to what we were doing and to just add these two equations together. So my y's are going to cancel out. A negative 4x plus a negative 5x gives me a negative 9x. And a negative 11 plus a negative 61 is going to give me a negative 72. Right? This is then something we can solve. Two negatives make a positive, so that will give me a positive 8. But I'm not done. As always, I need to take this and plug it back in. You can plug it into one of the equations where you multiplied, or you can plug it into the equations that were originally there. It does not matter. So just for sake of sticking to what I've been doing, I'm going to plug into that top one, and I'm going to plug in for x. So I have negative 3y minus 4 times 8 equals negative 11. So I have negative 3y minus 32. Add that 32 over. Give me 21. Then we'll divide by the negative 3. And I will get y equals negative 7. So we can choose to write our answer either way, but in this situation I have x equals 8 and y equals negative 7. Okay, then one last equation we are going to look at here. Right? When we first look at this, the one that we see that has matching is going to be my y's. So I'm going to look here. But again, when I look at this, both of my y's are positive, right? This has a plus in front of it and this has a plus in front of it. So when those are both positives, I need to multiply one of these equations by negative 1. Just to show you that it doesn't matter which one, I'm going to multiply this top one by negative 1. Okay, so my top equation becomes a negative 1 times a negative 4x, which will be positive 4x. Negative 1 times positive 2y, which will be negative 2y. And negative 1 times 13, which will be negative 13. My bottom equation is staying the same. Okay, once I do that, I've now taken care of it. I can now go to adding. So I'm going to add these two equations. 4x plus, remember that x is really a 1x, so 4x plus 1x gives me a 5x. My y's cancel because a negative 2 plus 2 is 0. And negative 13 plus 3 will give me negative 10. I can then solve this by division, and I'll get x equals negative 2. Again, we can plug this back in wherever we want to any of those original equations. So just for sake of showing that you can plug it in someplace else, I'm going to choose to plug this into the bottom equation. So I'm going to say negative 2 plus 2y equals 3. I'll undo that negative with a positive. And I will undo multiplication with division. Right? We have talked about this before. It's fine to get a fraction answer. Whether you write that as improper, mixed, or a decimal, it does not matter. But our final answer here will be negative 2, 5 over 2.